This video will show you how to complete lab 10. It's based on collision of objects in one dimension. So you can read the key concepts that are involved in this lab. You can see the overview of this lab and some of the physics equation that you need to know to complete the lab. Alright, so first play the video to see the phenomena. So basically you are colliding this object with this object. This kind of collision where the two objects separate after collision is elastic collision. So after finishing that, you can continue. So again, it's asking the question I just answered. And then I will let you guys answer this question, okay? So it's asking, in an absence of external forces, momentum is conserved in both elastic and inelastic collisions, true or false? So I'll let you guys answer that question. Here's another question. In absence of external forces, kinetic energy is conserved in both elastic and inelastic collision. You need to say if it is true or false. So you can decide that. So the next question is again true or false. The initial momentum of car 2 is 0 kg meters per second. After answering those questions, now you can go to phase 2 using known frame of 29.97 frames per second FPS. Calculate conversion factor from FPS to seconds and record in lab data to 5 decimal places. Now you have already done this kind of conversion before, so all you need to do is divide 1 by 29.97. That'll give you the time for one frame. Okay, so you can record that. I'm just recording some random number here, so you will need to do the actual calculation. So again, this is not the right conversion. I'm just putting some arbitrary number here, so 0.03012. Okay, so that's some number. And after that, click left tip of dimensioning arrow. So we have this tip here, so you can click that, and then click right tip of dimensioning arrow. So click that. Using known air tract length of 2 meter, calculate the conversion factor from pixel to meters and record in lab data to 5 decimal places. Okay, so we need to divide 2 meters by that number. Okay, so that'll give you the length of 1 pixel in meter. All right, so 2 divided by 1139. So you will put that here. So that'll give you again value of 1 pixel. I'll just put some arbitrary number here. You can use the actual calculation. So 2 divided by 1139. So I'll put 0018, something like that. And then what's the next one? So phase 3, click top right corner on card 1. So that's card 1. So click on the top right corner. Record the frame number along X pixel coordinate of last measurement in lab data. So go to lab data and then look at the last measurement. So we have frame 18. So here we are talking about elastic collision, and this is before collision. So put the time in frame, which is 18, and then you need to convert that to seconds. So you need to multiply that 18 by this number. Okay, 1 frame equals 0.0321 seconds. Okay, so you will need to multiply that. I'll just put some number here. I will let you guys do the calculation. So let's say that's 0.2012, like that, which is not the right answer, but I'm just putting some random number. And then horizontal position is 286 pixel. Convert that pixel to meters, so you need to multiply this number by this number, conversion factor. So again, 286 times 0.001803. Okay, I'll just put some number here. So let's say that's 0.302, like that. Do the calculation, and you can cross that. Continue to click top right corner of card 1 3 more times. Okay, so that 2 and then 3. So that will populate the lab data. So you see that it's populated now. Track final position of cart 1 by tracking top right corner 4 more times. Okay, so now this is after the collision. Okay, so the green one is before collision. Now they collided, and now we are looking for the position after collision. So that's the first one after collision, second one after collision, third one after collision, and fourth one after collision. Okay, so now you should have the lab data for after collision. And now we need to return back to the moment of collision. So let's see what it is asking. Track final position of cart 2 by clicking top right corner 4 times. So we are looking for the position of this one after collision. So before collision, its momentum is 0 because it's sitting at rest. Now for after collision, so let's click here. That's the first one, that's the second one, third one, fourth one. So knowing this position, we can find the velocity. Okay, so after clicking that, you will see the lab data after collision. So that's the data after collision. All right, and then let's go to phase 4. Now we will be finding the velocity by plotting position versus time. We know when we plot position versus time, the slope of that graph gives us velocity. So horizontal axis is time, vertical axis is position, and this is for cart 1, and this is before collision. Okay, so this will give us the initial velocity of cart 1 before collision. So plot scatter graph and then create the graph. So we want to show the regression or do the best fit line. So this number is the velocity of the first cart, which is on the left side before collision. So that's 0.580. So let's record that. So initial velocity of the first cart is 0.580. 0.580. Okay, and you can save that graph. Let's go to phase 5. Now we want to find the final velocity of cart 1 after collision. So time, position, and then we want to do the scatter plot and then create and then show regression, and that will give us the velocity. The velocity is negative in this case because after the collision it's moving to the left. Whenever object moves to the left, its velocity is negative. Okay, so that's negative 0.195. all right, you can save that. Let's go to phase 6. Now we want to find the final velocity of the second cart. So we don't need to find the initial velocity of the second cart because it's at rest, but the final velocity of the second cart is not at rest because we see that it moved to the right after collision. So to find that, again, plot position versus time, use the scatter plot, create, show regression, and again it's a positive slope because it moved to the right. So the velocity is 0.383. 0.383. okay, and then you can save that. Go to phase 7. all right, now using your initial and final velocity data and the law of conservation of momentum, determine the mass of cart 2. Record the mass in lab data to 4 decimal places. So basically we want to use conservation of linear momentum. So let me show you what that is. So this equation is the law of conservation of momentum. So we want to use this equation to find the mass of the second cart. Okay, so this is what we want to find, and now you can use all the data you have. I'll just show you what things we have and what we are finding, and I will let you guys do the calculation. Okay, so M1 is the mass of the first cart, which is this one 0.116 kilograms, so you plug that in here, and the initial velocity of the first card is this 0.580, that's v1I, and then m2 is, we are finding that's unknown, and v2I is 0 because initially the second card was at rest, so this is 0. m1 is again 0.116, which is this one, and v1 final is this negative 0.195, so plug that for this v1f, and then m2 is unknown, we were finding that, and v2f is this number. Okay, v2f is 0.383 meters per second, and then you will solve this equation to find m2. Okay, so I'll let you guys figure that out, and once you have that number, you will enter that number here. Okay, so I'll just put some random number here. I don't know what the exact mass is. I'll just put some number which is not the correct number. The next one, so let's see, determine the initial kinetic energy of the system and record in lab data to 4 decimal places. So we want to find the total kinetic energy. For that, you need to use this formula. So the total initial kinetic energy is 1/2 m1 v1I squared plus 1/2 m2 v2I squared. Here m1 is the mass of the first card, which is 0.116 kilogram. m2 is the mass of the second card, which we just found in the previous part. Initial velocity, you already know that, which is 0.580. You need to square that, and then initial velocity of the second card is 0 because it's sitting at rest in the beginning. So with that being 0, this part is 0, so that means all you need to do is find this part only. Okay, so after finding that, you can put your numbers there. So whatever answer you get, put that there. And then next thing is determine the final kinetic energy of the system and record in lab to 4 decimal places. So you will need to find the final kinetic energy just like before. This is the final kinetic energy, 1/2 m v1 final squared plus 1/2 m2 v2f squared. So you know the values for all these variables, mass 1 and mass 2, and final velocity of 1 and final velocity of 2, which is this one and this one. So using that, you can find the total final kinetic energy, and then you can put the values here. And then let's see what it is asking. Determine the fraction of kinetic energy that survives the collision and record in lab data to 4 decimal places. So this is ratio of final kinetic energy over initial kinetic energy. Take the ratio of 0.2012 over 2.932, and that will give you the fraction of kinetic energy that survived the collision. Okay, so let's say that's 0.6. Again, you need to find the actual number through the calculation. So this is for elastic collision. Now you need to do same kind of experiment for inelastic collision. So play this. So in inelastic collision, after the collision, the objects stick together. Okay, they don't bounce like before. So you see here they got stuck after the collision. Click the video 2 of the card colliding in the track. So you already did that. We'll continue. We need to answer a bunch of questions. So I'll let you guys answer these questions. All right, after answering those questions, now you can go to phase 9. Track initial position of card 1 by clicking top right corner 4 times. So just like before, click it 4 times. 1, 2, 3, and 4. So that will populate the data here. And after that, track final positions by clicking top right corner of card 1 4 times. So this is after the collision. So click 4 times, 1, 2 on the right corner of the first card, 3 and 4. Then go to phase 10. Now we want to find the initial velocity and final velocity of cart 1, or initial velocity of cart 1 and cart 2 and final velocity of the combined cart. So for initial velocity of cart 1, we'll plot time on horizontal axis and position on vertical axis, and then plot the scatter graph, create the graph, do the best fit line, so that gives us the velocity of the first cart. So put that in the lab data table. So that's 0.611, and then save the graph. Phase 11. Now we need to plot the graph for final position of the first cart. That gives us the final velocity of cart 1. So time on horizontal axis, position on the vertical axis, and then scatter plot, create regression line. So that's the final velocity of the first cart, which is 0.261, and this is positive because it's moving to the right after the collision, unlike in the previous experiment. And then you can save that. Phase 12. Now just like before, you need to find the mass of the second cart using the law of conservation of energy, law of conservation of momentum. So the law of conservation of momentum, I already showed you that this. So use your data to find the mass of cart 2. So mass of cart 1 is this 0.108 kilogram. Initial velocity of cart 1 is 0.611. Mass 2 is unknown, and velocity of 2 initial is 0 because it's at rest in the beginning. And then M1 is again 0.108. V1 final is this one, 0.261. And then V2F is also same because they are stock and they have the same or common velocity. So V1F and V2F are same, which is this 0.261. So V1F and V2F are same. And then the only unknown here is M2. So this thing is 0. Solve this to find M2. Okay, and then once you have that, you can enter your number here. I don't know what the right answer is, so I'll just put some random number here. So that's mass 2. And then kinetic energy initial, just like before, you can find the initial kinetic energy. So for that, you need to use this formula. So plug in all the known values to find that. So let's see, let's put some number here, and then you can also put your final kinetic energy, which is given by this formula. For final kinetic energy, the velocity for both the masses would be same. So this V1F and V2F would be exactly same because they got stuck after the collision and they are moving as a single mass. Okay, so you can plug your numbers and find the value. I'll just put some number here, and then you also need to find the ratio of Kf over Ki. So I'm not doing calculation here, so you will need to do that. Okay, so that's some number, and after finishing that, you can go to phase 13, and that would be everything for this lab. Okay, so that completes your lab.